Summary of comparative study of group second or second A. Okay, group second. Okay, outermost configuration elements: beryllium, magnesium, calcium, strontium, barium. बेमग का सरबा रा beryllium, magnesium, calcium, strontium, barium. Okay. Outermost configuration 2s2, 3s2, 4s2, 5s2, 6s2. Valence electron 2, 2, 2, 2, 2. Group second A, second A, second A, second A, second A. Okay. And outermost orbit 2, 3 orbit, 4th orbit, 5th orbit, 6th orbit. Period 2, 3, 4, 5 and 6. 2, 3, 4, 5 and 6. Block S block. All is S block. S block. S block. S block. S block. S block. Okay. All is S block. Okay. All is S block. All is S block. Okay. Physical state all solid. Oxidation state +2 for all. Most stable oxidation state +2 for all. Oxidation state which +1 for all. Displacement oxidation state which disproportionate in solution +1 for all. Atomic radius: beryllium is less than magnesium, is less than calcium, is less than strontium, is less than barium. +2 ionic radius: beryllium +2 is less than magnesium, +2 is less than calcium, +2 is less than strontium, +2 is less than barium +2. Okay. Ionization potential in beryllium ionization potential is very large of all elements, okay, of that group. Then beryllium, the ionization potential of beryllium is greater than magnesium, is greater than calcium, is greater than strontium, is greater than barium, is greater than barium. Okay, is greater than barium. Okay. Ionization potential: beryllium is greater than magnesium, is greater than calcium, is greater than strontium, is greater than barium. Oxidation potential: M equal to M plus 2, current plus 2 electron. Beryllium is less than magnesium and approxy is less than calcium, strontium and barium. All is approx same but greater than magnesium and beryllium. Reducing power: calcium, strontium and barium of reducing power all is approximately same but less than magnesium and beryllium, and reducing power is more of magnesium as compared to beryllium. Okay. Melting point: beryllium melting point is greater than, is less than magnesium, is greater than magnesium, and the melting point of calcium is greater than magnesium and less than strontium, and strontium, the melting point of strontium is less than beryllium. Effective nuclear charge: the effective nuclear charge, magnesium, calcium, strontium and barium all are same but all is greater than as compared to beryllium. Okay. Effective nuclear charge of all elements, that means magnesium, calcium, strontium and barium is greater than of beryllium. Effective nuclear charge. Okay. Next point. Nature of bonds. Next point. Nature of bonds. Okay. Electrovalent for all. Electrovalent bond for all. Beryllium and magnesium compounds on hydrous state covalent but ionic in hydrated state. Acid base nature: oxide bases, hydroxide bases, beryllium oxides, beryllium hydroxides, amphoteric, beryllium amphoteric. Okay. complexes formation, maximum for beryllium plus 2 and magnesium plus 2. Reaction, reaction with oxygen, then all but barium form metal oxide, and barium forms beryllium oxide. X2, MX2 for all dilute acid, M plus 2 and hydrogen gas, okay? And H2O, all react beryllium with steam, magnesium with boiling, calcium, strontium, barium with cold, okay? Steam, beryllium with steam, magnesium with boiling, and calcium, strontium, barium with cold. Solubility of compounds. Solubility of compounds. Beryllium hydroxide is the less than magnesium hydroxide, is the less than calcium hydroxide, is the less than strontium hydroxide, is the less than barium hydroxide. Principle of extraction. All are extracted from the electrolysis of their fused halides. Okay. Comparison of alkali and alkaline earth metals. Comparison of alkali and alkaline earth metal. It is very important. Alkali and alkaline earth metals show some similarities in certain properties, but they also differ in some properties. Similarities. Okay. Similarities. Alkali metals, alkaline earth metals, alkaline earth metals. Okay. First point. Like the alkali metals, alkaline earth metals are extracted by the electrolysis of their fused chlorides. Okay? Alkali metals extracted by the electrolysis of their fused chlorides okay. And alkaline earth metal is also alkaline earth metals also extracted by electrolysis of their fused chloride. Second point. Metals of both the groups are silvery white. Metals of both the group silvery white, soft, very light, very soft, very light, and all give characteristics color to Bunsen frame, to Bunsen flame. Bunsen flame. All are metals. All are metals. Okay. Alkali metals are extracted by the electrolysis of their fused chloride. Alkaline earth metals is also extracted by the electrolysis of their fused chloride. Metals of both the group silvery white, salt, very light, and all give characteristics color to Bunsen flame. All are metals. All are metals. Third point. Third point. Metals of both the group are malleable, ductile, and good conductors of heat and electricity. Metals of both the groups, both the groups are malleable, ductile, and good conductor, malleable, ductile, and good conductor, malleable, ductile, and good conductor of heat and electricity, electricity. Fourth point. Both the group of metals form colorless salts. Both the group of metals form colorless salts. Fifth point. All these metals become tarnished when exposed to air due to formation of oxide. Due to formation of oxide, hydroxide and carbonate, oxides, hydroxides and carbonate, oxide, hydroxide and carbonate. 6 point. Metals of both the group are highly electropositive. Metals of both the group are highly electropositive and do not occur in free state. Electropositive and do not occur in free state. 7 point. The metals of both the group are very reactive. The metals of both the group are very reactive. They are present in form of carbonates, sulfates, minerals and ores. Okay. The metals of both the group are very reactive. Okay. They are present in the form of carbonates, sulfates, and minerals and ores. Okay. 8 point. They react with water to form alkali and hydrogen gas. They react with water to form alkali and hydrogen gas. Okay. And as example, 2 sodium plus 2 H2O, that is 2 NaOH, sodium hydroxide plus H2 hydrogen gas, and Ca plus 2 H2O, that is CaOH whole twice plus H2, 9 point. They react with oxygen, hydrogen and halogen and form oxide, hydroxide and halide respectively. Okay. 4Na plus O2, that is 2Na2O, sodium oxide, 2Na plus H2, that is 2NaS, and 2Na plus X2, that is 2NaX, where X equal to chlorine, bromine, iodine. Okay. And 2Ca plus O2, that is 2CaO, Ca plus H2, that is CaH2, and Ca plus X2, that is CaX2, where X is halogen, where X equal to halogens. Okay. And next point, point 10. The metals of both the groups show fixed valency of oxidation state. The metals of both the metals of both the group show fixed valency are oxidation state. 11 point. All the metals are reducing agents. All the metals are reducing agent. All the metals are reducing agent because of more affinity towards oxygen. Okay. Towards oxygen. Okay. Similarities, like alkali metals and alkaline earth metals are extracted by their electrolysis of their fused chlorides. Metals of both the group are silvery white, soft, very light, and all gives characteristics color to buoyancy and flame. All are metals. Metals of both the group are malleable, ductile, good conductors of heat and electricity. Both of the group of metals form colorless salt. All these metals becomes tarnished when exposed to air due to formation of oxide, hydroxide, and carbonate. Metals of both the group are highly electropositive and do not occur in free state. The metals of both the group are very reactive. They are present in form of carbonate, sulfate, mineral, and ores. They react with water to form alkali and hydrogen gas. And they react with oxygen, hydrogen, and form oxide, hydroxide, and halides, respectively. The metals of both the group show fixed valency or oxidation state. all the metals are reducing agent because of more of affinity towards oxygen. Okay. Next, dissimilarities. Dissimilarities between alkali metals and alkaline earth metals. Alkali metals and alkaline earth metals. Okay. Dissimilarities between alkali metals and alkaline earth metals. Okay. Dissimilarities between alkali metals and alkaline earth metals. Okay. First, outermost electronic configuration. Outermost electronic configuration. Outermost electronic configuration is the outermost electronic configuration of alkali metal is NH1 and alkaline earth metal is NH2. Alkaline earth metal is NH2. Alkaline earth metal is NH2. Okay. Second point, valence electron. Valence electron. Alkali metals valence electron is 1 and alkaline earth metal valence electron is 2. Okay. Alkali metals valence electron is 1 and alkaline earth metal valence electron is 2. Third point, group. Which group of alkali metals? Then first group of alkali metals. First group of alkali metals and second group of alkaline earth metals. Second group of alkaline earth metals. Okay. Second group of alkaline earth metals. Fourth point, oxidation state. Alkali metals oxidation state is +1 monovalent and alkaline earth metal oxidation state is +2 divalent. +2 divalent. Okay. +2 divalent. Okay. Next, atomic radius. Then alkali atomic radius is less than alkaline earth metals because alkaline earth metals, the atomic radius of alkaline earth metals is greater than as compared to alkali metals. As compared to alkali metals. Okay. Okay. Next, oxidation potential. Oxidation potential. Then alkali metals. The oxidation potential of alkaline earth metals is the greater than as compared to alkali metals. As compared to alkali metals. Okay. As compared to alkali metals. Okay. Fourth point. 6 points. 7 point. Okay. Melting point. Melting point. The alkaline earth metal of melting point is the greater than alkali metals. Alkaline earth metals. Alkaline earth metals. Alkaline earth metal melting point of alkaline earth metals is the greater than as compared to alkali metals. As compared to alkali metals. Okay. The melting point of alkaline earth metals is greater than alkali metal. Is greater than alkali metals. Okay. Eighth point, density. Lighter than water. Okay. The density of alkali metals is lighter than water, and the density of alkaline earth metals is heavier than water. Is heavier than water. Okay. Is heavier than water. Okay. Next one. Point 9. Softness. Alkali metals soft metals. Alkali metals soft metals, but alkaline earth metals harder than alkali metals. Harder than alkali metals. Okay. Harder than alkali metals. Okay. Next, reaction with nitrogen. Okay, next point. Reaction with nitrogen. Reaction with nitrogen. Okay. Next point. Reaction with nitrogen. Okay. Then Alkali metals do not combine with nitrogen directly. Alkali metals do not combine nitrogen directly. Do not combine nitrogen directly. Okay. Do not combine nitrogen directly. Okay. Next one. Next one. Carbonates. Carbonates. Carbonates are stable. Carbonates are stable. Carbonates of alkali metals. Carbonates of alkali metals are stable, and but carbonates of alkali earth metal decompose on heating. Decompose on heating. Decompose on heating, and alkali metals do not combine with nitrogen directly, but alkaline earth metal combine with nitrogen directly to form nitride 3Ca plus N2 Ca3 N2. Okay, and next nitrates. Next nitrates decompose on heating to give oxygen. Alkali metals is decomposed on heating and to give oxygen, but alkaline earth metal decomposed to give nitrogen dioxide and oxygen. Okay, to give nitrogen dioxide and oxygen. Okay, sulfates, they are higher soluble and form alums. Alkali metals are highly soluble and form alums, but alkaline earth metals are sparingly soluble and do not form alums. Now, XIV, that means 14 point. Okay, 14 point. Reaction with ammonia. NH3. The alkali metals amides are formed. And 2Na plus NH3 NaNH2. Okay. Next point. Alkali metals hexamines are formed. As example, M plus 6 NH3, MNH3 whole 6. Okay. And fluoride, carbonates, phosphates, and oxalates. Phosphate and the oxalates are alkaline metals soluble in water. Alkaline metals are fluoride, carbonate, phosphates, and oxalates are soluble in water, but the fluoride, carbonate, phosphates, and oxides are for alkaline earth metals are insoluble in water. Okay. Hydrides of alkaline earth metals. Hydrides of alkaline earth metals are group second A. Group second A. The elements of alkaline earth metal magnesium, calcium, strontium, and barium, except beryllium, are react with hydrogen to form hydrides of MH2 type. Okay. The elements of alkaline metals. The elements of alkaline metals, the elements of alkaline earth metals. Okay, the elements of alkaline earth metals: magnesium, calcium, strontium, and barium, except beryllium, all react with hydrogen, to form hydrides, of MH2 type. Okay, M plus H2, that is MH2. Okay, Ca plus H2, at 800 degree Celsius, that is CaH2. Okay, CaH2, calcium hydride, and strontium plus hydrogen at 800 degrees Celsius is strontium hydride, and barium plus hydrogen at 850 degrees Celsius is barium hydride. Barium hydride is difficult to prepare. Barium hydride and magnesium hydride as prepared by reducing beryllium chloride or magnesium chloride with lithium, aluminum, hydrogen or lithium hydride. Okay, lithium hydride. Okay, beryllium hydride. Beryllium hydride is difficult to prepare. BeH2, beryllium hydride and magnesium hydride are prepared by reducing beryllium chloride or magnesium chloride with lithium aluminum hydride, lithium aluminum tetrahydride or lithium hydride. Okay, as example, 2BeCl2, beryllium chloride plus lithium aluminum tetrahydride is 2BeH2, beryllium hydride plus LiCl, lithium chloride plus AlCl3, aluminum chloride, and 2 magnesium chloride plus lithium aluminum tetrahydride is 2MgH2, magnesium hydride plus LiCl, lithium chloride plus AlCl3, aluminum chloride. Okay, properties of alkaline earth metals. Properties of alkaline earth metals. Okay, properties of beryllium hydride. Property of beryllium hydride. Okay, first property, beryllium hydride is covalent. Beryllium hydride is covalent. Beryllium hydride is covalent. Magnesium hydride is partly covalent and partly ionic. 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 Okay, and calcium hydride, strontium hydride and barium hydride are ionic and contain the hydride ion. Contain the hydride ion H negative. Okay, hydride ion. Okay, beryllium hydride is covalent. Magnesium hydride is partly covalent and partly ionic, and calcium hydride, strontium hydride and barium hydride are ionic and contain a hydride ion H negative. And okay, second point, beryllium and magnesium hydrides are covalent and polymeric, such as beryllium hydride and magnesium hydride. Beryllium and magnesium hydrides are covalent and polymeric polymeric such as BeH2N and BH2N and MgH2N. Okay, number of atoms. Third point. Beryllium hydride is less stable than other hydrides. Beryllium hydride is less stable. Beryllium hydride is less stable than other hydrides. Fourth point. Point 4. All hydrides are reducing agents. All hydrides are reducing agents. All hydrides are reducing agents and are hydrolyzed by water and dilute acids and evolve hydrogen gas. Calcium hydride plus 2H2 water is at calcium hydroxide plus hydrogen gas. Okay, next point. Point 5. Okay, 5 point. 1 minute. 5 point. Point number 5. 5 point. Beryllium hydride and magnesium hydride. Beryllium hydride and magnesium hydride both react with ethanol. Ethanol solution of diborane. Ethanol solution of diborane. Okay, diborane B2H6 and form borohydride BH4 negative ions. Okay, as example, BeH2 beryllium hydride plus B2H6. Okay, diborane B2H6 diborane is BeBH4 whole twice. Okay, beryllium borohydride. Okay, beryllium borohydride and magnesium hydride plus B2H6 diborane is MgBH4 whole twice. That means magnesium borohydride. Okay, 6 point. Point 6. 6 point. These hydroxide react with atmospheric carbon dioxide and form insoluble carbonates. These hydroxides react with atmosphere atmospheric, react with atmospheric carbon dioxide and form carbon dioxide and form insoluble carbonates, okay, insoluble carbonates, that is CaOH whole twice plus CO2, that is CaCO3 plus H2O, okay. 7 point. These hydrides reduce these hydrides reduce sulfates to sulfides, okay. These hydrides reduce sulfate to sulfides, okay. Pb, lead sulfate plus 2CaH calcium hydride, that is lead sulfide plus 2CaOH whole twice calcium hydroxide, okay. Structure, next is structure. Beryllium and magnesium hydrides are covalent and polymeric. Beryllium and magnesium hydrides are covalent and polymeric like BeH2N, okay, and MgH2N, okay. For example, beryllium hydride is polymeric and contain hydrogen bridge between beryllium atoms. The structure of BeH2N is shown. Beryllium, that is beryllium hydrogen beryllium hydrogen beryllium, that is a hydrogen this is beryllium, okay. Polymeric structure of barium hydride. This is the polymeric structure. Polymeric structure of beryllium hydride with a 3 center bond. With a 3 center bond. 3 center bonds, okay, with 3 center bonds, okay, with 3 center bonds. Polymeric structure is of beryllium hydride with 3 center bonds, okay. Beryllium has 2 valence electrons. Beryllium has 2 valence electron and hydrogen has 1 valence electron. It is seen that there are not enough electrons to form the normal electron pair bonds in which 2 electrons are shared between 2 atoms. 2 electrons are shared between 2 atoms. In this molecule or 3 center, 2 electrons, 3 center 3 center 2 electron. Okay, 3 center 2 electron bond is formed. Here 3 center bonds are formed in which banana shape, banana shaped molecule, in which banana shaped, banana shape, in which the banana shaped molecular orbitals covers three atom, hydrogen, beryllium, and contains two electrons only, and calcium hydride, potassium hydride, barium hydride are ionic solids. They contain divalent metals, contains like M2 plus and hydride ion negative. Okay, salvation or hydration tendency of alkaline earth metals. Next is salvation and hydration tendency of alkaline earth metals. The solubility of most of the salts of alkaline earth metals decreases with increase in atomic number. Okay, solubility. The solubility of most of the salts of alkaline metals, solubility of most of the salts, of alkaline earth metals, alkaline earth metals decreases. Alkaline earth metals decreases with increase in atomic number. Increase with atomic number. Okay, or atomic weight. But trend is reversed in case of fluoride and hydroxides. Solubility depends upon two factors, but the trend okay, but the trend is reversed in case but trend is reversed in case of fluoride and hydroxides. Case of fluorides and hydroxides. Fluorides and hydroxides. Okay. Then solubility depends upon two factors. Depends upon two factors. First is lattice energy of the solid. Lattice energy of the solids. Second is hydration energy of the ions. Hydration energy of the ions. The lattice energy of alkaline earth metal are much higher than lattice energy of alkali metals. Okay, the lattice energy is of alkaline earth metals, metals is much higher than lattice energy of alkali metals. This is due to effect of increased charge on the ions. The lattice energy value decreases as the size of the metal increases. Okay, the hydration energy value also decreases as the metals ions become larger. Okay, for solubility of substance, the hydration energy must exceed the lattice energy and moving down the group and moving down the group and moving down the group the metal ions becomes larger, due to which both lattice energy and the hydration energy decreases. Both lattice energy and hydration energy lattice energy and hydration energy decreases. Hydration energy decreases. Okay, or decrease in lattice energy favors greater solubility, but decrease in hydration energy favors lower solubility. These two factors are effective in opposite directions. Okay, or decrease in lattice energy, decrease in lattice energy, decrease in lattice energy, or decrease in lattice energy favors greater solubility, favors greater solubility and decrease in hydration energy, decrease in hydration energy, favors lower solubility, favors lower solubility, okay, favors lower solubility. These two factors are effective on opposite direction. These two factors are opposite direction. These two factors are effective in opposite direction. These two factors are effective in opposite direction. The net effect depends on which of the two has charged most with most of the compounds, and moving down the group the hydration energy decreases more rapidly than the lattice energy. And moving down the group the hydration energy decreases. The hydration energy decreases. And moving down the group, the hydration energy decreases more rapidly than the lattice energy, okay? That is why compounds become less soluble as the metal becomes larger. That is why compounds become less soluble. Compounds become less soluble. Compounds become less soluble as the metal becomes larger. Metals become larger, okay? But in case of fluoride and hydroxide, But in case of fluoride and hydroxide, but in case of fluoride, but in case of fluoride and hydroxide, fluorides and hydroxide, but in case of fluorides and hydroxides, the lattice energy decreases. The lattice energy decreases. The lattice energy decreases more rapidly than the hydration energy. More rapidly than the hydration energy. Okay? More rapidly than the hydration energy. Decreases more rapidly than the hydration energy. Hydration energy. More rapidly than the hydration energy. Hence their solubility increases and moving down the group. Hence solubility is their solubility increases and moving down the group. Okay, moving down the group. Okay, and the value of lattice energy for some compounds are hydration energies of alkaline earth metals ions are you can show. Okay, then the salvation of hydration tendency of alkaline earth metals. The solubility of most of the salts of alkaline earth metals decreases with increase in atomic number. Okay, but the trend is reversed in case of fluorides and hydroxides. Solubility depends upon two factors: lattice energy of the solids and hydration energy of the ions. The lattice energy of the alkaline earth metals are much higher than the lattice energy of the alkali metals. This is due to the effect increased charge on the ions. The lattice energy value decreases as the size of the metals increases. The hydration energy value also decreases as the metals are become larger. Okay? For solubility of substance, the hydration energy must exceed the lattice energy on moving down the group. The metal ions becomes larger due to which both lattice energy and hydration energy decreases. Or decrease in lattice energy favors greater solubility, but a decrease in hydration energy favors lower solubility. These two factors are effective in opposite direction. The net effect depends on which of the two has changed most. With the most of the compounds and moving down the group, the hydration energy decreases more rapidly than the lattice energy. That is why compounds becomes less soluble as the metal becomes larger. Okay? But in case of fluorides or hydroxides, the lattice energy decreases more rapidly than the hydration energy, and their solubility increases and moving down the group. The values of lattice energy of some compounds are hydration energy, alkaline, or some metals. Okay? Next point, lattice energy and hydration energy value of alkaline earth metals at 25 degrees Celsius. Okay?